Hi everybody, once again I'm back to offer online lessons to the YouTube community. My name is Erisa and today I'll be teaching you something about integration of trig functions. In lesson 9 we talked about integration of powers of sines and cosines. Today we want to talk about integration of products of sines and cosines. Okay. Integration of products of sines and the cosines. This is what we want to discuss today. To integrate products of sines and cosines, we make use of the factor formula. The factor formula. If you are to integrate the products of sines and the cosines, then we must have knowledge of the factor formula. So it is driving us back to trigonometry. Let's briefly try to write down the factor formula. But I will begin by reminding you how the factor formula is developed. Okay, you have learned that, okay, factor formula. We know that if you have a sine of two compound angles A plus B, okay, this produces sine A cos B plus sine B cos A. And the sine of the difference of two compound angles, okay, will be equal to same thing, sine A cos B, only that this is minus sine B cosine of A. Okay, now how do we develop the factor formula from this expansion? Okay, the additional theorem. How do we get the factor formula out of this? Let's add these two, sine of A plus B plus the sine of A minus B. Okay, let's try to add these two. Adding the right hand side will produce twice sine A cos B. Why? The reason is this and this will cancel out in the process of addition. One is negative and one is positive, so when you add it cancels out. Now, how do we make use of this? Okay, let's see. I'll first of all write the 4 before attempting to integrate a product of sines and cosines. Let's look at also sine of A minus B. Okay, the sine of A plus B minus the sine of A minus B. Okay, let's go back here and subtract. When you subtract, this makes this a positive, and therefore it makes this part a positive. Okay, negative and negative is a positive, so you end up with okay, you'll get a 2 sine B cosine of A. Okay, now since angle A is more than B, we prefer to begin with A's, okay, and then B's follow. So I write sine of A plus B minus sine of A minus B as 2 cos A sine B. Okay, angle A is more than angle B, so it is a more convenient way of recording the factor formula. What about cosine? If you have a cosine of angle A plus B, you remember this is cosine of A cosine of B minus sine of A, sine of B. Okay, so cosine of A minus B also gives us cos of A, cos of B, but it is a plus. Okay, sine A, sine of B. So go ahead and do the addition. You'll end up with the cosine of A plus B plus cosine of A minus B. Okay, it gives you, if you will look at the mathematics involved here, it is a 2 cosine of A, cosine of B. So cos plus cos gives us 2 cos. You know, it is very easy to remember cosine than sine, because sine somehow, you know, a cosine starts and sine like that. But with the cosine, it is the cos or sine. Okay, what about if we take cosine of A plus B, okay, minus the cosine of A minus B. Okay, so if you subtract, you try to be careful in the process of subtraction. If I do subtract these two, okay, the negative will change this to negative. This part, the first part here will cancel out. Then I will have a minus sine A sine B and another minus sine A sine B. So I get a minus 2 sine A sine B. Okay, that is cos A minus cos B. So these are really very, very important in integrating products of sines and cosines. Let's try to bring now the four results together and see how we shall make use of them when you're integrating products of sines and cosines. All right, so I write here a small summary. Okay, right here some kind of summary to remind you that whenever you have, okay, let's begin with sine. Let's not change the order in which we have written our results. So if you have a sine of angle A plus B plus sine of angle A minus B, okay, it will give you 2 sine A cosine of B. Okay, if you have sine of A plus B minus sine of A minus B. Okay, the result we have got is a 2 cos A cos B. So these four are very, very important when you're integrating products of sines and cosines. And you know, you should be able to derive these results. Don't really mess up or try to forget something. It can always be derived. I have shown you how it is done. So remember, the factor formula can also be written in a different form. Okay, let me show you with only one. The rest you write down. But I prefer to use this when I'm integrating. So if P equals to A plus B, and then Q equals to A minus B. Okay, if you add these two, P plus Q will be 2A. Okay, meaning that A is P plus Q over 2. Okay, and the P minus Q will be a 2B, meaning that B is P minus Q over 2. So we can come and, you know, rewrite these four in another way. So we can write that if you have the sine, of P, now A plus B is P, and add to the sine, okay, of Q, taking P, and instead of A plus B, now we have P and Q as single angles, okay? This will give us 2 sine P plus Q over 2. then cosine of P minus Q over 2. And the rest you can substitute. But, you know, this is, yes, this is good, but not so good to use in integrational products and the introductional products of sines and cosines. This is the best way of using the factor formula when you are integrating the products of sines and the cosines. This will take you through a lot of, solving equations, and you spend too much time. So I always discourage my students from using this factor formula, the factor formula in this format, and I always tell them to use the first. Okay, so let me show you how it's done with an example. Look at this example. Okay, they want us to integrate sine 4x cos 2x by dx. So what are we looking for? We are looking for a sine, okay, of A cosine of B. Since A is more than B, that's what I'm trying to emphasize. The angle A is more than the angle B. So we are looking for the product sine A cos B. Now, what gives us sine A cos B is what we are looking for. Okay, so remember what we have just derived. We have sine of A plus B, okay, plus the sine of A minus B will give us a 2 sine A cos B. Okay, so I'm going to put here a 2. Much as I don't have a 2, or no, I'll put here 2, then I write sine 4x, then cosine of 2x, and we see what it gives us this product. So this is going to be sine of 4x plus 2x, then plus sine of 4x minus 2x. Okay, let's now subtract. We have the sine of 6x. If added to the sine of 2x, it will give twice the sine of 4x cosine of 2x. But when you check the question here, we don't have this constant 2. So what we do, we divide, okay? We divide and have a half. Okay, that's a bad color. Let me select a better color. Let me use black. Okay, already. If you have a half of sine 6x plus sine 2x, then it will give you a sine 4x cosine of 2x by dx. So what does that mean? It means that, okay, if I integrate sine 4x cosine of 2x by dx, then it will be the same as integrating, okay, sine 6x plus the sine of 2x by dx. Okay, so what do we end up with? Let's write the answer. This is halfway. Remember, integrating a sine, you get negative cosine. And I always refer to lesson 9, what we discussed yesterday. Okay, this is going to be the sine, the cosine rather, going to be the cosine of 6x, but we differentiate the angle 6x and divide, okay, minus the cosine of 2x out of 2, then plus a constant of integration. Ladies and gentlemen, we have integrated sine 4x cosine of 2x by dx. It is really very simple. Let's look at example. This is example 1. Let's look at example 2. Remember, this is the 10th lesson, okay, in integral calculus. We are moving on. Look at this example 2. It is a product of two sines. And when do we have a product of two sines? That is when we are having a difference of two cosines. So we shall write the solution. Okay, We know that if you have cosine of A plus B and you subtract cosine of A minus B, you're gonna get a negative 2 sine A sine B. At this stage, you now feed in the product that was given the equation, and the product given to us here is the sine of 5x sine of x. So let's put a negative 2 so that we can trace the expansion where it is coming from. So this is going to be cosine of 5x plus x minus cosine of 5x minus x. Okay, so what do we get? The cosine of 6x minus cosine of 4x gives us negative 2 sine 5x sine x. So we are trying to create the equation to trace where the expansion came from. And now the next thing to do, divide through by negative 2, you're going to get negative a half into cosine of 6x minus cosine of 4x is equal to the sine of 5x, then sine of x. So next is to now integrate sine 5x sine x by dx. It will be the same as integrating negative a half of, okay, cosine 6x minus cosine 4x by dx. And this is really very simple. Okay, what do you get? This is negative a half of, okay, sine 6x out of 6 minus sine 4x over 4 and plus a constant of integration, and you are done. Example 2, they want us to integrate cosine 6x cosine of 4x by dx. So let's look at this. How do we solve such a problem? Okay, we know that if you have cosine of angle A plus B plus the cosine of angle A minus B, then you're gonna get 2 cosine of A, okay, cosine of B. Now, you have been given cosine of 6x, cosine of 4x. Let's put here 2, much as it's not appearing in the equation. We have ways of manipulating it and doing away with it. This is gonna be cosine of 6x plus 4x, then plus the cosine of 6x minus 4x. So what do we get? Okay, what do we get here? We get cosine of 10x plus the cosine of 2x will be a 2 cosine of 6x cosine of 4x. Now let me divide by 2, okay, and take away this 2 from here. It works out, and then now it looks like the equation. So what does it mean? Let's try to integrate. Integrating cosine 6x cosine of 4x by dx, you will end up with a half times the integral of cosine 10x plus cosine of 2x by dx. Integrating a cosine, you end up with a positive sign. So this is a halfway of sine 10x out of 10 plus sine 2x out of 2 then plus a constant of integration, and you are done. So the trick or the magic lies in recognizing the factor formula, what gives me what product is what I need. Okay, maybe one or two example and we call it a day. Look at example 4. This is the last example we are looking at today. So let's try to look at this and solve it. Remember, if you have cosine and sine, okay, cosine takes the biggest angle and then sine the other angle, then that is sine minus sine. Remember what we wrote down, okay? So we have sine of angle A plus B minus sine of angle A minus B gives us a 2 cosine A sine of B. We prefer to write, the trig ratio with the biggest angle first. Now, if I have 2 cosine of 7x, then sine of 5x by dx, then this is coming from the sine of 12x minus sine of 2x. Okay, so if you are integrating from 0 to pi over 2 cosine 7x, then is sine of 5x by dx, then the same thing as integrating 1/2, okay, from 0 to pi over 2 of sine 12x minus sine of 2x by dx. Okay, so what do we end up with? A half. Okay, integrate sine, you end up with a negative cosine of 12x out of 12 minus, okay, now plus the cosine of 2x over 2, okay, we are integrating from 0 to pi over 2. So let's feed in the limits. This is a half, okay, we have cosine of pi over 2, okay, minus cosine of 6 pi over 12, then minus lower limit, which is cosine of 0 over 2 minus, okay, cosine of 0 over 2. Okay, what do we get? The cosine of pi is a negative 1, so this is negative 1/2. And the cosine of 6 pi is 1, so this is 1 out of 12. Okay, so if you have a half minus, okay, what do you end up with? The LCM is 12, that is 6, so this minus 7 over 12, so the answer is negative 7 out of 24. But you can try to compute it, I'm just using my head, so you have your calculators, try to work this out. So ladies and gentlemen, our lesson ends here today, and we have integrated the products of sines and cosines. So tomorrow, some other time to come, we're gonna see what is coming ahead. But I will send these links and post these lessons on YouTube. Try to share with your friends so they can have this knowledge, and let them subscribe. Subscription is free. Okay, you only need to have your mobile data or you have your Wi-Fi and access these lessons. Make sure you share this work so you can help somebody who is suffering down there under lockdown, students aren't going to school. So this is the best opportunity to make the best use of these resources. Okay, I'm doing this for free. I'm not paid anything. Maybe if you want to appreciate me, I appreciate that, but it is a free lesson for you. Just go to YouTube, subscribe, and don't forget to hit the notification bell. That way, if I upload a new lesson, you'll be notified immediately. Mr. Kiria and the rest of the community of Wairaka College, the headmistress and all the teachers, I send you greetings. You know, it is not an easy time right now. Students are outside there, you don't know what they are doing, but you know, come November, December, they have to pass. So we are doing our best to help them out. I send greetings to everybody watching these lessons, and you know, I love you so much.